Hello everyone, I'm Aseem Jakhar, founder of Exploity. Today we are going to be talking about the impact of GenAI on software security. And I have with me Chris Wysopal, co-founder and chief technical officer of Veracode. So tell us more about your latest research on AI-generated code security.
So we're seeing a lot of companies now starting to really dive into using these generative code tools. Why wouldn't they? It gives you a 30 to 50% productivity increase. Think about expanding your development team by that much. So there's a really big compelling reason to use them. They're built into IDEs in some cases. But the challenge is, like with most things in technology, we dive ahead, use new technologies because of the perceived benefits, and we don't think of the perceived downsides. So I've been looking into some studies that have come out of Wuhan University, NYU, Stanford, which have been taking different ways of looking at how this is changing coding and what is the security aspect of that code that's coming out. Is the rate of vulnerabilities the same, lower, or higher than you would have with just normal human developers?
Yeah. I mean, I tried. I developed code sometimes, and I tried Copilot, and oh my God, it is really good. So The amount of code that it generates is really helpful, but for sure, you can't do anything about the security implications.
Yeah, so a few of the studies basically came to the conclusion that between around 30% to 40% of the code that's generated will have a vulnerability in it. And it turns out, we look at the Veracode data of human-generated code, and it's about the same. And it makes sense, right? It was trained on human-generated code. It's learned how to code the way that an open source developer would code. So if that's the training set, that's how it's learned to code. So we have to think about that. So if we have similar vulnerability density, but we're creating code at a faster rate, how does that change how we as security people have to think about ending up with a secure application at the end of the day?
Do you think that AI will be like self-inspecting in the future with respect to the generated code to look at security? Because it's the same LLM models that have learned from GitHub, GitLab, all the source code. And those models have also learned from research papers and blog posts on security.
Right. Yeah, and they've learned from university students writing a program for the first time and putting it up in GitHub, right? So it's hard for it to determine, is this good code to learn from or bad code to learn from? And that's the challenge when you get this really large data sets and unsupervised learning. You just get what's out there and you hope it's pretty correct. I think the solution for this problem is to have curated data sets that are known pieces of good code. That have been inspected with tools and people to say, hey, this is a reference known piece of good code. And use supervised learning so that we know what's going in, and then we see that what's been trained on is giving us the correct output. So I think it's all well and good to use these general purpose code generation tools to write code, but I think we need specialized LLMs to actually fix code.
If you look at all the source code, all the code available, open source code available, and training from that is pretty straightforward, right? Mm-hmm. You just take the code, feed it to the model, let it run through. But when it comes to creating specialized models with respect to having a good understanding of cybersecurity or secure code, where would the secure code come from?
Exactly. So. One of the things we're doing at Veracode is we are creating these training sets.
Oh, nice.
So we're finding reference examples of this is what SQL injection looks like. On this line of code, there's a problem, right? And this is how you would fix it. Like this is the piece of code that fixes that problem. And you can train it to understand what bad code looks like, and then you train it to say, this is what you want to change it to. And it's actually very good at doing that. I mean, the GPT algorithms were originally developed by Google to do language translation. Like if you see this, turn it into this. And so the tools are very good at doing that, but you have to have the right training set. Yes. You can't just hope looking at open source is going to get you the right weights in that model to know this bad code becomes this good code. And it's actually not that hard because you can go language by language, CWE by CWE, and just have maybe 10 examples of SQL injection in Java and train on that. And it actually learns pretty well how to fix that problem just from that training data set.
For companies or for enterprises that are reliant on generating AI or having AI generate code for them, what would be your advice to the developers or to these enterprises? Specific best practices like do this, don't do this, do this.
So I think the first thing is to raise awareness that these tools generate insecure code just like your average developer does. There's been studies to show that people have confidence in the output of these LLMs more than they have confidence in the output of just maybe a Stack Overflow answer, right? They actually think because of the way the LLMs present the answer with really good language, there's an over-trusting of the output. So you have to disabuse people of that notion, right? To let them understand, hey, we need to treat this just like it was made by a junior developer, right? We don't know whether it's going to be secure or not. So that's the first thing. The second thing is you're going to have higher code velocity, right? Because you're getting big blocks of code from a prompt, and it's much easier for a developer to write more code. That's the 50% productivity increase. So when you get higher code velocity, you're going to get more check-ins, you're going to get more builds pushed to production in a unit of time. So it makes automation even more of a requirement. So shifting left, building security testing into your repo pull requests, or into the IDE when you're cutting and pasting code, test it right there. Have that automation on the testing part to use static analysis, dynamic analysis, interactive analysis. Use the different testing techniques in an automated way because you're generating the code in the automated way. So I think that's the second thing. And then finally, when these tools identify an issue, use an automated remediation LLM. So we have Veracode Fix. There's other ones out there that people have made. Don't rely on the developer to try to have to fix the problem because they already don't have enough time to fix all the problems they're generating the normal code way. How are they going to fix all the problems when they have 50% more code each day? So automate fixing. And I think automating fixing is really going to be a game changer for just application security in general because I see that as the biggest problem. Developers have been building in automation, they have been finding issues, but oftentimes they sit in the backlog for a really long time or never get fixed. There's never enough time to do it. So automating the fixing, I think, is the most important part of solving this problem.
So I take it as awareness, automation in development, CI/CD, and automation in fixing these issues. Oh, those are great points. Thank you for joining us, Chris.
Excellent. It's been great to be here.
We were speaking with Chris on the impact of GenAI on software security. This is Aseem Jakhar signing off. Thank you.